All right, Algebra 2, lesson 85. Just have a couple more this year, so hang in there. Let's go.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, lesson 85. We are gonna find polynomial roots again. This is part 2 of our Finding Polynomial Roots series. It's like Netflix, except we're finding polynomial roots, even better. So let's say we've got a cubic polynomial. So for example, we talked about this in the past. We have, like, if we have an x cubed plus a cubed, that's just x plus a times x squared minus the product a times x plus a squared. Okay, and then if you have a difference of cubes, x cubed minus a cubed, this is factored this way. X minus a, and then you have x squared plus ax plus a squared. So let's find the roots of this first example. Y equals x cubed minus 27. Okay, so we're gonna factor this because it's a difference of cubes. So up here, we're gonna look here, and this is our difference of cubes. So we can just follow this pattern, okay? So we wanna find the root, so we're gonna set that to 0. And this is how we factor it. X minus, well, what's the cubed root of 27? 3. And then x squared plus the product, which is 3x, plus the square of this guy, which is 9. Okay? All right, so we know one of our roots has to be x equals 3. But what about this guy? Well, let's use our discriminant. This is a quadratic equation. So what's our discriminant? B squared minus 4ac. So we're gonna see if we even have a real root. Okay, so a real root, remember, if you end up with a 0 in the discriminant or a positive number, then you have one real root or two real roots. Okay, well, let's see what b squared minus 4ac is. Well, b squared would be 3 squared minus 4 times a, which is 1, times c, which is 9. So this is gonna be 9 minus 36 equals a negative number. So that means there are no real roots here, okay? These are complex roots. All right, so our only real root is x equals 3. That's it. Let's try another one. So that was 1. Let's do 1b. Here's example 1b. Y equals x cubed plus 64. Okay, so this time, this is a sum. This is a sum of 2 cubes. So we're gonna follow this pattern. We're gonna set that to 0 and we're gonna factor this. X plus 4, because the cubed root of 64 is 4, times x squared minus the product 4x plus 4 squared, which is 16. Okay, so far so good? Well, we know one of our roots has to be x equals negative 4, because that will make this parenthesis 0. All right, but what about this? Well, let's plug that into our discriminant and see if that gives us some real roots. So b squared minus 4ac, so 16 minus 4 times 1 times 16, doesn't look like it. 16 minus 64 is also negative, so these are these are complex roots. All right, so this is our only answer right here, x equals negative 4. So far, so good? All right, well, let's try another example. We're gonna step it up a notch just because that's what we do. And we're gonna see if we have any real roots of this equation. X to the 6th minus 64 equals 0. Okay, well, we're looking for a difference of 2 cubes, okay? Well, technically, this guy is a cube because x to the 6th is just x squared cubed, right? X squared cubed, okay? So that's how we're gonna factor it. So we're gonna factor it x squared minus the cube root of 64 is 4 times x squared squared, which is x to the 4th, plus the product, so 4x squared, plus the square of 4, which is 16. All right, well, this guy can factor nicely. Look at this. This is going to be awesome. That's just a difference of 2 squares, so that's x plus 2, x minus 2. Remember to factor the difference of 2 squares, the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. And this is all times this. So this is completely factored. Okay, so far our roots are x equals -2 and 2, okay? So we want to know if there's any x's that will give us a 0 in this parentheses, okay? So let's just look at this guy for a second. Well, how about we graph it? So y equals x to the 4th plus 4x squared plus 16. All right, well, what does that look like? Well, I can't even see it, so I'm going to zoom out a little bit, and it's all the way up there. So remember, we're trying to find where our y is 0. Well, it does not cross the x-axis at all, so there's no solution to this. So these are our only real solutions because this will never equal 0. So it's impossible. All right? Boom, right there. All right, let's do 2b. Not 2b. We're not doing that. No, you just have to finish it. Whenever someone says 2b, you have to say, or not 2b. But I'm not gonna do it. I'm not gonna do it. We're doing 2b. Or not 2b. Okay, so this is a sum of 2 cubes. Remember, x to the 9th is just x cubed, okay? So the cubed root of x to the 9th is x cubed. All right, and the cubed root of 27 is 3. So this is actually what this looks like. Okay, so now that makes it easy to factor. So we have our cubed roots all times our cubed root squared. So this would be x cubed squared, which would be x to the 6th minus the product 3x cubed plus the square of 3, which is 9. Okay? All right, well, this is kind of a sum of 2 cubes. Well, we're going to make it 2 cubes. So how do we factor this? The same way we factored this. So x plus the cubed root of 3. Okay, all times x squared plus cubed root of 3 times x, remember the product, and then the square of this, which is just the cubed root of 3 squared. Well, what's 3 squared? That's 9. So this is just the cubed root of 9. Okay? I know that's a little weird, but that's how you can factor it, and that's how you can find your solutions, because now that we have this quadratic equation, we can test it in our discriminant to see if there's a solution. And then we also have this guy, which is x to the 6th minus 3x cubed plus 9. Okay, so we already know that there's one root here. Well, what x will make this 0? Well, the opposite of whatever this is. So the opposite of the cubed root of 3 is one of our solutions, okay? Now, you can probably guess that these aren't gonna give us real solutions, but we're gonna graph it just because we can. All right, so how do we graph that? Let's start with our polynomial equation with a degree of 6. We're gonna say y equals x to the 6th plus 3x cubed plus 9. All right, so we can't see it. Let's see where it is. Where is it? Okay, that's that weird function up there. It doesn't look like it crosses the x-axis, so there's no value that will equal 0, where y will give you 0, okay? Let's do x squared, so y equals x squared minus the cubed root of 3. Okay, so how do you say the cubed root of 3 with fractional exponents? Well, you can just say 3 to the 1/3. 1/3. Okay. This is all times x plus the cubed root of 9. Okay, so 9 to the 1/3. Okay, and look at that one. That doesn't cross the x-axis either. So there's no real solution on both of those polynomials. So let's go back to our answer. So this is our only real solution. Negative cubed root of 3, which is not pretty, but that's it. That's what we got. Okay, well, what if you don't have like a sum of 2 cubes or a difference of 2 cubes or anything like that? No problem. Let's just graph it. So here's example 3. Let's just plug it into our graph. Example 3 looks like this. 3x cubed minus 7x squared plus 4x minus 12 equals 0. Let's graph it. 3x cubed minus 7x squared plus 4x minus 12. All right, so there's where it is. Now, if I wanted to be more specific, I'm just gonna change this y to a 0. And look what happens. It tells us where these are. So if I click over here, I have a root. It is 2.454167-ish. So you can round that to the nearest whatever. So our x, our only real root, is approximately 2.4542-ish. Okay, so that is example 3, that's all it is. So here's a theorem that I'm gonna give you. This is called the rational root theorem. And it says, if a polynomial equation has rational roots, then use the rational root theorem to find these roots. To do so, follow these steps. This is on page 600, but I'm gonna put them up here on the screen for you. So we're gonna do example 4 by following these steps. All right, so here's example 4. So I wanna find the rational roots of this equation, x cubed plus 2x squared minus x minus 2 equals 0. Now I could graph it, but I'm gonna use the rational root theorem. So the first step in rational root theorem, write the polynomial in this form. So we did that. So see how the highest degree is first, and it goes all the way down to the lowest degree. Step 2, so we're gonna find all the factors of this coefficient and this coefficient. Well, all the factors of this guy are just 1, -1, 2, -2. All the factors of 1 are just 1. And you could say -1 because -1 times itself, whatever. But then we're gonna build fractions with all of this over that. So basically it's 1 over 1, -1 over 1, 2 over 1, and -2 over 1. So these are our possible roots. This is not necessarily our roots, but these are our possible roots. So what we're gonna do is we're gonna divide this polynomial, this cubic equation by these roots and see if it works. Okay, so how do we do that? We could do this, like we could test this one by saying x minus 1 into x cubed plus 2x squared minus x minus. So we could divide this out, dirty monkey smell bad, whatever. But we're gonna use synthetic division. So remember, synthetic division means write this root here. So we're gonna go 1, and then we're gonna write our coefficients. So 1, 2, -1, and -2. I'm just getting my coefficients right up here. All right, synthetic division, remember, bring this down, that's a 1. Multiply 1 times 1 is 1. 2 plus 1 is 3. Multiply 1 times 3 is 3. Add. Multiply 1 times 2 is 2. Add, and you get 0. What? So this is a root. Now let me show you one that's not a root, just so you can see what's happening. So if I plugged in 2, let's see if 2 works. 1, 2, -1, -2. So remember, bring down that first one. 2 times 1 is 2. Add 4. 2 times 4 is 8. Add 7. 2 times 7 is 14. Add 12. You get a remainder. So if you get a remainder, that means it's not divisible. It's not a root, okay? So 2 is not a root, but 1 is. Well, now that we know that 1 is, guess what else is? So this is x squared plus 3x plus 2. So here's what we have so far. We can factor this with our x minus 1, which we know this is a root, times our answer to that division problem, x squared plus 3x plus 2 equals 0, okay? And look, this can be factored as well. This is x plus 2, x plus 1. So look, this just lays out our roots. So our roots are 1, -2, and -1. Boom. So you just have to pick one of these possible roots, plug it into synthetic division, and see if it gives you a remainder. If it gives you a remainder, then it's not a root. So try the next one. If that doesn't give you a remainder, then you have 1. So you can use that root and the answer you got to that synthetic division problem, because basically if you're trying to figure out like if 3 is a root of 24, well, yes, because there's no remainders. So now you know 2 roots. 3 and 8 are both factors of 24. Let's try B. B's always, classic B. Not necessarily easier. It's usually more challenging. So we're going to find the roots of this equation. X to the 4th minus x cubed minus 8x plus 8 equals 0. Okay? So it's already lined up nicely, but what we're gonna do is we're gonna add an x squared term, okay? So if there's no x squared term, we're just gonna say no x squared term. No x squared term. All right, we're gonna find all the possible factors of 8 and all the possible factors of 1, which is just 1. So our factors of 8 could be 1 or -1. So I'm going to say positive or -1, positive or -2, positive or -4, and positive or -8. Okay? So I'm just going to choose one of these. All right? I'm going to choose, let's see. I'm just going to choose 1. So let's see if 1 is a root, or x minus 1. Okay? So let's write our coefficients. 1, -1, 0, don't forget that 0, -8, and 8. All right, bring down the first one, multiply, add, multiply, add. Ooh, this is nice. Multiply, add, multiply. Oh, look at that, add. No remainder. Okay, so what are our factors so far? So we have x minus 1 is a factor, and this guy is a factor. Okay, so this is x cubed, because there's 4 terms there, plus 0x squared plus 0x minus 8. Okay, in other words, you don't even need those. So here's our factors. X minus 1 times x cubed minus 8. Ooh, look at this. This is a difference of 2 cubes. This is a difference of 2 cubes. So we know how to factor that. So this is how we factor this. This is going to be the cubed root of both of these. So x minus 2, and then the square of the cubed root. So x squared, then the product, but it's the opposite of that sign. So 2x plus the squared, which is 4. All right, so now we know that these two are factors so far. So x equals 1. These two are roots so far. So x equals 1 and 2 so far. But what about this? Well, let's see if it works in our discriminant. B squared minus 4. We can use the discriminant to see if there's a real solution because it's a quadratic equation. All right, so b squared would be 4 minus 4 times 1 times 4. Doesn't look like it. This is 4 minus 16, which is negative. So there's not a real solution there, so these are only real solutions. Boom. All right, we're gonna do one more. This is 4C. Find the real roots. And it's important to note that the directions are asking for the real roots. Okay, if you were asked to find all the roots, this would be a different ball game. But you're just trying to find the real root. So that's why using that discriminant works to kind of save a lot of time, because that'll tell you if you're even going to have real roots. All right, so here's what 4c says. 2x to the fourth minus 9x cubed plus 2x squared plus 9x minus 4 equals 0. All right, 4, 3, 2, 1, 0. So that we don't have to fill anything in with zeros or anything like that. Now we're gonna do step 1 is we're gonna determine all the factors of this guy and this guy, okay? So there are two different factors here. So this is 1 and 2, positive or negative 1 and positive or negative 2. The factors of negative 4 are positive and negative 1, positive negative 2, and positive or negative 4, okay? So now the possible roots are gonna be all these guys over these guys, okay? So we're gonna have positive or negative 1 over 1, positive or negative 2 over 1, positive or negative 4 over 1, but we're also gonna have positive or negative 1 over 2, positive or negative 2 over 2, and positive or negative 4 over 2, okay? Well, let's simplify this. So this is our P, and this is our Q. We've never really had to do this in the past examples because we've never had a coefficient for that first term. So since there's a coefficient of that first term, that we're gonna have different factors, but in the past it's just been 1, so we don't really need to divide by 1 every time. Okay, we have to divide by 1 and we need to divide by 2. So these are all the possible factors. Okay, so let's just simplify this. Well, this is just positive or negative 1, and then this is positive or negative 2, positive or negative 4, and then positive or negative 1/2. And then this is another positive or negative 1, so this is a repeat. And this is another positive or negative 2, so this is another repeat, okay? So we don't need to include those. So these are our possible solutions. So we just have to choose one of these and plug it in, see if it's a root. We're gonna choose the hard one. And we're gonna say that, try to see if 1/2 is a root, okay? So let's plug it into synthetic division, write our coefficients, 2, negative 9, 2, 9, negative 4. Bring down the first one, 2, multiply 1/2 times 2, that's nice, just 1. Add, multiply 1/2 times negative 8 is negative 4. Add, multiply 1/2 times negative 2 is negative 1. Add, 1/2 times 8 is 4. Ooh, look at that. Add, and you get 0. Boom. This is a root. So that means x minus 1/2 is a root. Well, what's a better way to say this? This is, remember, this guy over this guy. So this is actually 2x minus 1. So remember, the root is the positive version of that over that. If 1/2 is a root, that means 2x minus 1 is a factor, okay? So what are you left with? You're left with this, 2x to the third minus 8x squared minus 2x plus 8. All right, well, you could actually factor out a 2 there. So if I factor out a 2 there, then it's just 2x minus 1 times 2 times all this x cubed minus 4x squared minus x plus 4 equals 0. Now if I divide both sides by 2, this is kind of a long way to do this. That cancels that 2. And then I'm left with this. I'm going to create a new page here. So I'm left with this guy. So 2x minus 1 times x cubed minus 4x squared minus x plus 4. Okay? So now guess what? We can use the rational root theorem to find the roots of this. It's like 2 problems within 1. Awesome. Okay, so what are our roots here? Positive or negative 1, positive or negative 2, and positive or negative 4. All right, and remember this was just 1, so we don't really need to include that, and we don't even need to consider P over Q because Q is just 1. So these are our roots. So let's try one. Let's try one. Let's try one. Literally, we're gonna try the number 1. Okay, write our coefficients: 1, negative 4, negative 1, and 4. Bring this sucker down, multiply, add, multiply, add, multiply, add, 0, boom. So this is a root and this is a root, so that means x minus 1 times x squared minus 3x minus 4 works. All right, is this factorable? It is. X minus 1, cheeks and tats, x and x, negative 4, positive 1. Boom. So our roots are, I'm going to put my negatives first, negative 1, positive 1, and positive 4. That's satisfying. I don't care where you come from. That's extraordinarily satisfying. So is saying the words extraordinarily satisfying. It's satisfying. Oh, and don't forget, this guy is a root too. So this guy is a root, and it's also, we've got 1/2 is also a root. Don't forget that, because that was part of the whole first part of that. Okay, that's nice. So that's 4 different roots, which makes sense because what did we start off with? We start off with a quartic polynomial. So it makes sense that there's up to 4 roots. All right, that's it. That's pretty cool, right? Good job.
Flack